Okay, so lab number one will be, we need you to be familiar with the, the microcontroller. This is the embed, they call it embed board. And this embed board, okay, it includes the microcontroller, which is LPC 1768. That's the name, or the, let's say, the part number of the microcontroller, which is embedded in that embed board. Okay, so because embed board can have like a sensor like this, can have like LEDs, okay, more inputs and outputs on the pins here. Okay, and this microcontroller, this embed board can be powered by USB cable, which should be connected to your laptop. It can be powered from there, and at the same time, the data can be transferred from, from your laptop to this embed board through that, via that USB connector or cable. So that's the objective is just to be familiar with this environment, using using this embed in general. In this part here, I'll be posting this for you, this lab manual. So in this first part, it's just like introducing the microcontroller itself, the embed itself. Okay, its dimension, and how many pins he has, like 40 pins arranged in two rows. Okay, as you can see here, we have one row here and the other row in the back here. It's hidden, but this is the other one. So 20 here and 20 the other side. So in general, we have 40 pins. Okay. Okay, this is 1.1 inch spacing. This is for students who are like planning to use this embed for their projects, SDP projects, for example, or any advanced projects where they have to integrate this embed board inside another PCB board. So if you want to integrate this one in your PCB, so you have to either you should have the data sheet for that. This one, there they will give you the layout and the exact spacing between pins here, or you can have physical one and you can have a ruler with you and you can measure this distance between 1 and 2, 2 and 3, and so on, and you can take a consideration that one. So look, and once I got this, I didn't went in details and check, that one. What 1.1, it's too big, spacing between the pins. But okay, ignore that one and just focus on the embed itself. Okay. And thank you for this remark. I'll take it in consideration for sure. So this is general introduction about the embed. They call it embed development board or embed board simply. The architecture of this one, okay, it has, so if you get this embed, physical embed, Engineer Ayman, he will give you the chart for that. This is like small business card for this embed. They call it like that, business card for that one. So there you can see pin by pin the function of each one of them and how you can connect them to external peripherals, like external components. For our labs, will focus mainly on analog inputs and output. And as you can see here, we have from 15 to 20. This is pin number 15 till pin number 20. Those can be used as analog inputs to the microcontroller, except pin number 18 can be either input or output. So you can use it as output to control a switch, for example, okay, or to take this 3.3 volts, okay, inside this coming from this board, I can supply an external small circuit outside of this one. Also, the last lab, the one I was talking about, the new one, which is a PWM, the pulse width modulation, will be mainly using this one. If you can have a chance to come to the lab, so we can generate pulses and you can see them through oscilloscope. you can measure the duty cycle. You can measure the period of that the generated signals. Can be sine waves. Can be sawtooth. Can be triangular waveform. So those depend on the code written in this microcontroller. So mainly we'll be using this for advanced projects. You can use the CAN to communicate with another board and use Ethernet, for example, connection. Now, this can be used, but will be used this send and receive serial pins will be used through the USB itself. Okay, so this will be using like something as we call it TeraTerm. Yes, I remember the name TeraTerm. This is like another window. Once you run it, another window will appear, and in that window we can see the answers in there. Okay, you can type your code. For example, just an example, you can type A equal 1, B equal 2, A plus B equal Y. So this Y, which is the output, this can be displayed on external window, where you can see what is happening inside your microcontroller. So this is one of like maybe the second lab. We can start using that one, or the third lab we'll start using the TeraTerm. We'll give you the link from where you can download that TeraTerm and how you can make a settings for that. This is in after a couple of weeks, coming weeks in China. So here we have a ground. For example, you have external circuit where you need like plus and minus or plus and ground. So plus can be used from here, because once you supply your you connect your embed to your laptop, so the energy will be coming through that cable. So this will be able to give you back or use it and give you like output voltage 3.3 volts. And this will be used also during one of our labs, especially when we need to use like analog outputs. We need to vary, like for example, vary voltage. Okay, so we can use 3.3 as output through a potentiometer. Okay, grounded here, and the output of this potentiometer, which is variable resistor, the output of that one can be connected to analog inputs, and you can see through this TeraTerm what is happening once we adjust physically that potentiometer. We can make it up and down. So the TeraTerm, which is the other window, black window like this, will show us, values of volt, like between 0 and 2.3 volt. So you can make like variable source, variable DC source between 0 and 3 volt using that, this embed controller. I'm talking in general, giving you some ideas, and I'm trying to introduce this embed for you, what you can do with it, and for what we'll be using it also. Okay, this is the architecture of that for more, students or needs, or the student that they need to be more familiar with the architecture of that and what is the inside of this embed board. So they can have this in general, but they can also go to the website. They have more explanation about how they can use those, in and out, and the source and everything, okay, from this embed board. I skip that one. Okay, this is not we're not in computer engineering, or computer science. Maybe they have they studied the architecture of the microcontrollers. For us, how we can use them. So this is our task. So we'll show you how you can use it. After that, okay. So now for the equipment, to have, okay, to run the whole lab, we need to have like microcontroller with USB cable. So this will be given to you. You should have, of course, computer or laptop with you, and a web browser because everything will be done through the browser. Okay, once you connect your microcontroller to your laptop, the laptop will recognize your embed board, and it will open a folder for that. By default, will be created and opened for you. Once you go to that folder, you double click on it. You are inside your microcontroller or embed, and there is like a icon for a website. We double click on it. This website will open, and everything will be done through that website. This is why we needed to have they're asking you to have like a web browser, like Internet Explorer or Google Chrome or Firefox. And there you can type your code and compile it there. You know what is compiled means, and you pass it through a compiler, and the compiler will check it. If there is no error, it will give you a file, output file. That output file, you can upload it now, send it to your microcontroller, and microcontroller will execute, because microcontroller will be your slave. Okay, it will execute whatever you send it to him through this to your code, through your code. Okay. Yeah. So since you don't have microcontroller with you right now, so this step here will be bypassed, because we need you to have microcontroller. You connect it through USB to that PC, to your computer. As I told you, this embed will be created automatically. And in that folder, you will find a link for where you can open the browser. And there now in the browser, you should create like account. So each student, you should have accounts. Otherwise, you cannot access to your microcontroller. Okay, you cannot do anything with your microcontroller. Sorry. Let me open the browser. I'll stop here a little bit on the browser. I don't know which one is it. Share this with you. That's the one that was already shared. Can you see this one? Yeah, here. This osembed.com. I think once you open, you double click on that folder. I don't have any in my office. I don't have embed. If I have it, I can do it in front of you. But I think once you connect and you click on that icon, okay, the one I was talking about, which is this one here, the embed. I think you've seen this window also. This will bring you to this window, and there you have to create. Just move this here. You have to create, let me log out, create your account. 1 second. Okay, do you see my browser, right, ladies?
We see it.
Yeah, so there, look, login or sign up here. So there you can, this is the all of you should do that. But I prefer that you don't do it right now till you get your embed with you. Okay, so you select your email and sorry. This is for one who already created the account. So create an account here. There, okay, you select your email, okay, existing email. I don't know after that, because yeah, I think he knows me. That's why he's asking for password. There's a sign up here. So this sign up, so email address, okay, you create your username, password. Those are mandatory fields. You have to fill them. First name, last name, okay, the country. Just click on these ones here and click sign up. So by doing this, you can have account now. Once you have the account and you go to AR, this is the name of the microcontroller, the company name, embed. So there you can now sign in, sorry. Okay. Yeah, I hope I can remember my password, because I didn't use this for a long time. Okay, maybe. So is verifying my credentials. Yeah, okay, so I'm in. So there you can see that he's giving me access to their website, and there you know you can create. Let me check here. I think we should have the microcontroller there. We will give us access to where we can type the code. Yeah. So we should have the microcontroller connected. There is a blog here. Is in case if you need to use this microcontroller for your SDP project or even outside in the companies, you need to let them use this microcontroller. So we have a blog here where you can post your blogs, comment on some of the blogs, ask questions, and get answers about anything you know that you cannot use it in your using that microcontroller, or if you have any errors that you cannot fix. Here there are like people that they can help you. So once you do, you create your embed code, you can compile it. Yeah, right now we will try to look for, yeah. So I open it, even if I don't have my, because I had like different before, because I have history in that website. That's why he's trying to open what he had before, but I cannot compile, okay, and send to my control because it's not ready, it's not connected. I'm giving you roughly a general structure of this embed microcontroller. So step number 2, you have to create your account. Okay, after that, you can run your program. You have steps here how you can use it. I'm going to skip this and we'll do it next week, inshallah, as soon as you can get your microcontroller. So we can do it quickly, and you can even at that time we can start lab number 2 also. Okay, so this is one of the examples. You can either you can even copy it from here, paste it in the window of embed code, and compile it there and send it back to microcontroller, and you see that the flash, the LED, it has 3 LEDs. You can check once you copy this code. You can even instead of LED 1, you can make LED 2, and you can see that LED 2 is blinking with this. You are making it, or the code will make this one on and off 0101 like this. So we'll make it on and wait for 1 second, make it off, and so on. Wait for 0.2 and go back to okay 1 and wait for 1 second, 0.2. We're making it like more on than off, like this. Okay, you can control the time of making it on more than off by reducing this number and increasing this number here. Okay, and it will be all the time running. Now, there's one thing. Once you upload, once you compile and you upload the file, once you compile, the output file will be generated and save it in the same folder, which is the embed folder. It will be automatically saved there. So you go there. If you name it, for example, your lab 1, blah blah blah, in name. You take that. You see it here after compilation, and if everything is okay, you will see that file here. You have just to click on it, okay, and drag it again. You can drag it on that embed, which is the controller itself. It will be sent automatically there. And okay, you see on the embed itself of this small program that there is one LED, small one, surface mount LED, not the big ones that we have in electronics, fundamental electronics, but small one. It's we call it surface mount, and you can see it on and off and off, and you can play with those numbers here to make it more on, more off, and so on. This is just an introduction how you can play with your, let's call it a gadget. Okay, and you see that you are communicating with it. Okay, yeah, you're creating the program, send it to him, and he's understanding what you are asking for. He will do it. So for this, you'll be able that to see that your microcontroller is working perfectly. So you can go and do more codes and send it to him, or send them to him. I skip these, so you can read them. Okay, because those paragraphs, they're just taking this small code and explaining part by part. And I believe that since we started the lecture with Professor Faisal, he already started talking about DICE include and what this library done and everything. Okay. So those on this page, they're trying to explain sections of that small program. Okay, and when they find the program code here, as I told you, you can. It has 4 LEDs, not 3. So LED 1, 2, 3, and 4. You can change from LED 1, as they are requesting now here, to LED 4, and you can run it again. You can see that you switch it from LED 1 to LED 4, and the LED 4 will follow. So the lab work will be these. We have another one here. Please check what is the difference between the previous one. So two similar codes, but there's like small difference, and you can see what is the difference and why it is working, why it is not. So this can be verified by your controller or microcontroller, and you can see if it's working. You can see that there is no maybe LED will make more on than off. Maybe it's not working. There's error, something like that. So this is one of the tasks that you have to do. The other one, okay, friend, yeah, here you have to debug. So one of your friends, she wrote this, and it was not like working. And remember the blog, I think I was talking about in your in the website. Maybe okay, she recognized you and she sent you this code. You have to debug it. So you have to find what is the error. You tell her your error is X in this line, that line, and you can fix it for her. So the task here is just to find the error. Where is it? Same thing in here. Okay, find and correct the faults using information from error message. Yeah, from here, those are once we compiled that, we got those errors. So from here you can fix, okay, identifier, for example, the digital out. We have digital out here is undefined, and digital out. You have to read these and check what is the problem and fix it. Okay. So those are 3 tasks that you have to do them. You can practice what is what is before this title here. This is for practice, and after this is for your lab report. Task 1, 2, and 3. Okay. So create your own layout and introduce the lab as usual. What you should do and what is requested from you, and after that you can if you need, you can talk a little bit about the microcontroller in your point of view, how it works. You can copy paste from somewhere else, just make reference, but make something readable and something that can be or understandable. I can understand, and you can go after that to the tasks and explain one by one and conclude your lab report. Okay, I think I'm done here. Last week, Engineer Asma, she introduced to me something else, which is very interesting. Sorry, I'm sorry. I had like a signal system lab this morning. I think here, yeah. Simulator, yeah, that's one. I'm going to give you that link, and we have a simulator. Okay, so you can copy the code that you have in your lab report. You can copy it here. You can run it, and you can see. As you remember, the LEDs, those are the surface mount LEDs. If you can, you see my screen, right? The browser.
Yes.
Yeah. So yeah, this is the embed board. This is the first time I'm using this web browser here. I mean this website, but it's similar, 100% similar to the physical one. 4 LEDs, the black ones here. So once you run them, I think let me load the demo. That's the demo here. Okay, this is one of LEDs. You see here, because you're asking it to print F this sentence. This is why it's printing that sentence, and given the states of the LED, so 10, 10, 10, and so on. So if I make it like, for example, 50 seconds, I don't know if I load run here. I have to run. Look here, the blinking of this LED. I will make instead of LED 1, make it LED, let's say 3, for example. 3. So I think this one should blink, and with this speed here, run. Okay, it's compiling. Yeah, you see. Now I switch it from LED 1 to LED 3, and because I divided the time by 10, it was 500 milliseconds. So now 50 milliseconds, and it's blinking like this, quickly like that. So this one example. Okay, you can even this one here, if you don't need to display it here. This is like similar to TerraTerm I was talking about. You can run your program, your code in a physical one, embed, and you can open TerraTerm, and you can see the result. You can see physical LED blinking and the text on your screen and displaying whatever you're saying here. Okay. So maybe I can change the text. This is my first code. Okay. So I'm sorry for changing that. I'm saying sorry to him. Just an example. It's run. I think, yeah, there's an error here. I made some. Here. Go back, go to demo. Yeah, I removed this here. This is an example, okay? There's something he didn't like what I wrote. But anyways, this is one, just give you an introduction to how you can use this simulator. I'll copy this link and paste it for you in your Blackboard so you can have access to it. And you can use it from now. You can be familiar with the lab itself, lab manual, till you get your physical component or embed board, and you can run them again, and you can be familiar or communicating with the physical board instead of simulating them. But this is good exercise for any project or any lab or any experiment. It's better to go through simulation, because you'll not damage your components or your embed board. So if it's running, if it doesn't run, so you can make it running here till it's running. You can copy this one to your browser, your account, and send them or upload them, those codes, upload them to your physical microcontroller, and you can see physical actions in there.